That's the reward, huh? Everyone's like, yeah, I won that mark. Welcome to the ACE808 review seminar. No, unfortunately not. That was a lie, but I'm glad you all are here. We're going to be starting in 2 minutes. Before that, if you have any questions, let me know. Uh, but yeah, I'm glad all of you are doing good, even if it's fake. Fake it until you make it. Yeah. Yes, the slides will be posted. Um, and the recording will also be posted. Do you guys have any questions? Hmm. Don't join the breakout rooms. I created a breakout room for named meditation. In case you feel overwhelmed during the presentation, please go to the meditation room, have some rest, eat something, and come back. But we'll be having the main review seminar here. I think it's a nice thing to have in a Zoom meeting, in case you feel overwhelmed. So that's a safe space in case you're interested. But yeah, let's start the review seminar. Oops, I shared the wrong one. Let me share the actual one. Right, can you guys see my screen? Oh, let me also have the chat open somewhere so we can see what you guys see. Can you guys see my screen? Yes. I'm not going to start until I see 20 yes. 3, 4, 5, 6. Okay, great. Welcome to the Winter 2024 AMACSS review seminar for AO8. The seminar is hosted by me, this name here, and Elankrit, who's in the chat and will help you guys out. So if you have any questions, ask in the chat. Also, I'll also monitor the chat. So in case you have any questions, see. Now, today's agenda is going through some of the most important topics of the course, and we will do some past final exam questions in the mean way as well. And also, this is a good chance for you guys to ask your questions about anything that's missing. So we're going to start with functions. Now, you guys have learned about function runtime, the functions have different number of operation, and it depends on the sizes and the inputs they get. And operations are in general defined as anything that involves math. Is it a comparison? Is it a summation? Is it a negation, multiplication? Anything is considered an operation. And for example, the number of iterations you have in your for loop will be an extra type of operation. Your if statements are another operation. Your checks in a while loop are operations. And our inputs are your data types, from lists and strings to numbers and integers. And size is considered to be either the length of a string, the length of a list. It could depend on what exactly the data type you have is. It was just like a quick overview of runtime. I guess you just quickly caught in the course. And we're going to have an example from the 2022 final exam. So as we go through, we have different examples, and these examples are probably easy enough for you guys to solve, but I'm going to go through them since there's a lot of them and we don't have time. But if you have any questions or if any part of the example is not clear, definitely ask. That's the only way we can make sure you're all on the same page. So for example, here you have a function that starts with a for loop, has an if statement somewhere in here, and then ends. And now you're asked to given like example input list of that 5 and a value for the second argument, which results in the most iteration of the loops. So does anyone have any answer just for warm up? That was like a spoiler. Anyone suggesting anything? So basically what you're trying to do is you're trying to give an example list as to the input of this function such that you maximize the number of iterations this for loop gets. Well, the question is here, given an example, let's say there's a list of 5 elements being input here, and there's some item as our second argument. Now we want to have the most number of iterations of the loop. In other words, we want to have the most number of for loops running. Exactly. So as you guys mentioned, we could have 5 elements and the item is not in the list. Why? Because this way you're going to be checking through all the items in the list. You can also check the if statement and it's never equal to true. So you're going to be just going back through the loop again. Keep in mind, if the item number 6, for example, was inside the list, like this was 6, then your for loop would terminate here. So once you see if the last is equal to the item, it will return true. However, if the 6 is outside, it will go outside the loop. So it will not execute return true. It will go back and it will execute return false. So putting 6 inside the end of the loop will not make any difference. Like it will have the same number of if statements being considered. Yes, if item is in the end of the list, it works. So there are different examples, and this is one of them. But the key idea here is that you want your item to be either in the end of the list or not in the list. You don't want it to be in the middle or in the beginning. And this was the final exam question. So you can see it's pretty easy. Like, and a lot of you just gave me correct answers. So please be confident. Like, if you're going to exam, be happy, have some shine around you, go for the exam, take all your strength to it, and make sure you get the marks for these easy questions like the one here. Now, this is a visualization of the iterations just to be on the safe side. So, the first iteration, you check for number 1, then on the second one, you check for number 2, then for 3, then for 4, then for 5, and ultimately you just return false. If this was 6 here, for example, then you would just return true. So it won't really matter if it's 6 or 5, but what matters is it's not in the beginning of the list. Yes, the code will definitely work because, we are having 2 different return statements based on if the item's inside the list or not. No, if the item is not inside the list, we will not do a 6th iteration. The reason for that is the for loop here will only run for the items in the list. How many items do we have? We have 5 items, so it will run 5 times. It doesn't care what is inside it. It doesn't care what's happening. As long as you have 5 items, it will run 5 times. Now, if this was a while loop, like we had while, well, this won't be correct, but like if you had some while loop saying while you have not yet found ELT in the list, etc., then this will keep running for eternity. But this is a for loop, so it will not run for more than 5 times. So don't be tricked by these type of things. And here you see that the last time just returned true or false, depending on the output. Now, just to reiterate what we went through. So a for loop will only run for let's say finite amount of time. Like how many times it's going to run. In the first line that you call for loop, that's where you already know how many times the for loop is going to run. But a while loop will run until there's a condition. And that condition could be never satisfied. Your while loop will just go all the way to infinity. Or that condition could be satisfied in the first iteration, so we're done. And that's a key difference. If you do not know how many times your loop should run, you should use a while loop. If you know how many times it should run, you should use a for loop. So make sure you know the difference between these two, as it could get tricky. Now, the same example, here we want to do the least number of iterations. Instead of, why does it jump? It's crazy. So we are trying to do the least number of iterations. I'm pretty sure you guys can quickly answer this, so I'm going to go through. If you want to do the least number of iterations, the first item in the list will be equal to what we're looking for. This way, the first time we go through a for loop, this if statement will be true because we found the item, and will return true, and so the function is done. And here's like a demonstration. The first iteration, you check is it is inside the list. It is, so return true, and done. One iteration. And this is the example we went through. So this is a pretty easy example, but you can find harder types of questions with the same idea. And please practice. Being able to trace through a program without actually running it and just going through it in your brain is important. Whether you're checking your code, whether you're trying to understand how many iterations we'll have, etc. All of them together will define your skill as a programmer to be able to think before writing code. Someone asked if this is empty list, there will be no iterations, right? So for example, if you're saying for any item in an empty list, it could get tricky. I don't remember if it either gives you an error because you don't have anything in the list, or it won't run. I don't remember on the top of my head which one occurs, but yeah, if this is running, it will skip the for. But I think it will give you an error because there's nothing in the list. But I don't know. Oh, it satisfies? Okay, that's good. So it will just finish in the first row. All right, moving on here. So this is the same function we've been seeing before, the contains function. And bring the chat lower so I can see. And I have a second function called same elements. And this function gets two lists, list one and list two. And for each item in the list one, it will check if that item is inside list two. If it does not find any item, so if it sees that that item is not inside list two, the moment that happens, it will return false. And the reason for that is even if one of the items is not matching, then they do not have the same elements, right? There's at least one item that's not in the list two, so you're done. Otherwise, we'll just keep checking all the items, and once it reaches a point that all the items in list one have been checked and all of them are contained in list two, then you just return true. Every item in list one is inside list two. So I'm going to ask a random quick question from you guys. Let's say we have list one equal to 1 and 2, and list 2 equal to 3, 2, and 1. Now, these two lists are not equal. If I call same elements on list 1 and list 2, do I get true or do I get false? Okay, false, true, false. Which one should I believe? So you can trace through the program, right? You're going through each item of list 1. What do you do? Yeah, that does. Well, you could argue that there's no precondition. Let's ignore precondition for now. That's all. Let's assume there's no precondition and we're running this. Do we get true or do we get false? Your list one is number 1 and 2. Exactly. That's true. Why? Because we'll check item 1. Item 1 is inside list 2. We'll check item 2. Item 2 is inside list 2. So we're done. We return true. So same elements is only checking if list 1 is a subset of list 2, not if it's equal to it. That's why we add a condition here that their length should be equal to. Now, since the length should definitely be equal to, we cannot have list 2 being larger than list 1. In other words, this will not be a valid example. And if you want to make it valid, you have to get rid of 3. And as a result, now same elements is in fact checking for the fact that these two lists are equal. So you can see when our function is not defined like that, with a precondition, we are able to satisfy the property. Well, anyways, that was just a quick example. So as you saw, we use the comparison operator as a way to understand if the length is equal here. And the worst case and best case is, if you think about it, the best case is the one that you quickly exit. The worst case is the one that you just keep going through the for. And that's how you can find your most and least number of comparisons. The question is here, given list 1 length 5, list 2 length 5, so length is matching, what will result in 3 calls to contain? And there are a lot of examples for this one, but the key idea is if you just want to make 3 calls, you want the first 2 calls, the first 2 items that you're checking to say, yes, I'm contained. In other words, you want these 2 ones to be contained. And your third call, the last call, you do not want the third call or the third item to be in the list because you want to exit. So the third one is not in the list. The way you want to visualize it here is list one, list two. List one's first item is in the list. List one's second item is also there, but the third item is not. As a result, you will run this. Okay, next iteration, you will also run this. Okay, next iteration, and you will run this one, but it will fail. And you will return false in the end. So you went through the loop 3 times, and as a result, you satisfy 3 calls to your contains function. Exactly. The order of items in list 2 doesn't matter because contains is checking for all the elements, right? What contains does it goes through every single element of list 2 to see if it matches the current item at hand. So the order doesn't matter. Now, it will probably affect the speed a bit. Like here, it will be a bit faster because 1 is right in the beginning, 2 is also right in the beginning. So we quickly find this in list 2 and we're done. If 1 and 2 are in the end of list 2, it will take a bit longer, but the result is still the same. Great question. Let's move on. This is just an example we went through. Again, item 1 checks it is. Item 2 checks it's in. Item 3 checks it's not in. So we return false. And we run through the loop 3 times. So that's 3. Now we can again play with the same idea, right? You have list 1 length 5, list 2 length 5, and now we want to have worst case right. Do you guys have any suggestions? Same function, but new inputs such that we will have the worst case right. They're opposite order to each other. What do you mean? Yeah, that should work. Yeah, that works. But like the order doesn't really matter. Like I guess like your example will work, but the order doesn't. Exactly. So there are 2 scenarios. Either yes, it will return false immediately. There are 2 scenarios. One of them is, as one of your friends mentioned, the lists are equal. Like you don't even need to change the order. Let's say list 1 is 1, 2, 3, 4, 5. This is LST1. LST2 is, again, 1, 2, 3, 4, 5. There's no need to change any order. What happens is your function is trying to see if all the elements of list 1 are inside list 2. So it has to run for all of them until one of them fails. But here, none of the numbers will fail. All of them will be, yeah, I mean, here, there, go to the next one, go to the next one. So it will run for 1, it will run for 2, for 3, for 4, for 5, and then it will return true in the end. That's one approach. The second approach is, as one of you guys mentioned in private, is ignoring the last one. In other words, we have the same thing, 1, 2, 3, 4, but let's say here we have 10. And list 2 is again 1, 2, 3, 5. This will also work. What? Because the first 4 elements that we're checking in list 1 are all included in list 2. So we'll run 4 times. And once we reach 10, we'll also run again. And in that scenario, we just return false. But we still go through the 5th iteration because we have to check number 10. So both of these approaches will run 5 times. The key here is the first 4 elements should be the same. Or let's say this way, the first 4 elements of list 1 should be inside list 2. It doesn't matter where they are located in list 2, as long as they are there, and we keep going. But the last element of list 1 could be anything. It won't matter. It just affects the output, but the worst case running time stays the same. Now, if you really, really want to make it the worst, then as your friend mentioned, you want to like change the orders. Like, if you want to put 1 in the end, like do nasty things to make it last longer. But in the end of the day, the number of iterations is usually the most important thing, right? Yes, the function will return false immediately once it finds an element in list 1 that's not in list 2. Because that will not satisfy contains. So if not contains will be satisfied, and so you'll return false. And once you return, the function is done. You'll go to sleep. Okay, are we all on the same page? Has anyone been to the meditation rooms? No? Okay, that's good. Right, do you guys want to move forward? Or am I too slow, too fast? Can you guys hear me? Am I muted? One. Okay, good speed. Nice. Good speed with the like. Okay, let's go. Yes, I love that enthusiasm. And this is an example here we just went through. Now, just to wrap this up, if you want to have the worst case running time, what you'll do is, what matters is the first four. So either LSD does not contain the item in the end, or it just has it as the last element, doesn't matter. And that's how you keep going. So in general, if you want to put it with some math, which is kind of funny, if you have two lists of length n, then in the worst case, how many comparisons will you do? So in the worst case, what you'll end up doing is for any element in list one, you have to check all the elements in list two, right? So in other words, there's a lot of math here. Let me first just give you the intuition. Like nothing here matters. The only thing that really matters is n squared. I want you guys to just think about the idea that if you have list one here, let's say your list one, I'm going to show it as a line, right? For any element of list one, you have to check it in list two. So if this is LSD1 and this is LSD2, for any element of LSD1, you have to check, is it this one in LSD2? Is it that one? Is it this one? Is it this one? Is it this one? No, you just keep going, right? So if you think about it, if LSD1 has n elements and LSD2 has also n elements, you're going to have a general comparison to the order of n squared, right? Because for any element in LSD1, you're going to compare it to all elements in LSD2. So you have n elements times n elements, which gives you n squared. And that's all that matters. Because in the end of the day, is it 1n squared? Is it 2n squared? It doesn't matter. N squared is the big factor. Like if n is in the order of millions, n squared is much bigger than n or anything else. Now, how do we calculate it exactly is the next. Is everyone okay on the intuition of why it's around n squared? Awesome. Now, if you remember, one of your friends mentioned something nasty, which is we don't want the function to be done quickly, right? We want the first element that LST1 is checking to be like in the end, right? So it takes a lot of time to go through these one by one. In other words, what we want to do is we want to have them to have reverse order. So the first item of LST1 should be in the end of LST2. So we do a lot of comparisons. The second one should be, again, pretty close to the end. So we do a lot of comparisons. Now this will squeeze in a bit more, time because the model has to go through more checks and checks. So that will result in you having more checks compared to just n squared. Now, how do we get n squared again? If you remember what the function is doing is for any element in LSD1, it's checking it over all the elements in LSD2. For example, if you're at x1, it's going to say, is x1 the first element? No. Is it the second element? No. Is it the third one? And so on. So it's going to check it n times. And the same thing for x2 and so on. So since for any number in LSD1, you're checking it for any number in LSD2, you have an order of n squared. Now, this is not exactly n squared, and the reason for that is, for example, some element in the middle, if it also exists in the middle of LSD2, you don't need to check all the elements, because the moment you reach here, you're done. You know that the element exists in place 2. So if you think about it, on average, you're not going to check for all the n elements. It's going to be some portion of those n elements, and that's why it's not n squared, it's half of n squared. But the intuition that it's about n squared is more important. Now, how do we count the exact number of comparisons? In the scenario that LSD1 and LSD2 are the same list, just in reverse orders. It's pretty easy. How? Let's just do it by normal count. For x1, you're going to do n comparisons, right? You're going to check the first element, second element, all the way in the end. So you have n. For x2, you're going to do the same thing, but the moment you reach x2 here, you're done. In other words, you're going to have only n minus 1 checks because you never reach the last element. And if you follow the same order, then you see that this next one will only be checked for n minus 2 times. And this will keep going until the last element. Now, the last element is xn, right? Xn is not in the list. So you have to keep checking as we go. Remember, if xn is not in the list, you will check the first one, no, second one, no, third one, no, you'll keep going. So even though the last one, like if you think about it, you might say, oh, if xn was in the beginning of LST2, then I just needed one check. But we could do a trick here. We could put the last element as an element that's not in list 2. And the reason we can do that is because this is the last one, right? Doesn't matter if this is inside list 1 or not inside list 2, we're done. We're done with the function. We need any element prior to xn to be in list 2 to ensure that the function will keep running. But the last one is not important. So 1 minus last one, the xn minus 1, will be having 2 comparisons. And instead of reaching 1, we suddenly reach n because we could change this pattern for the last one. And if you keep counting these, you'll reach what it is in the bottom. You'll have n times n plus 1 over 2 minus 1 plus n. If you sum these up, you get this as a math, which will be then this. Now, this example is, you know, a nice generalization of what we went through, right? We started from contains, we also went through same elements, and we did a lot of good progress through these functions. And I'm now sure you guys have a better sense of how you can trace through these different small mini functions and understand their worst case and their best case scenarios, along with also counting the exact number of comparisons. Is everyone clear on this one? Oh, everything good? It depends. If in the exam they ask you what is the order, like what is the general idea, what is the pattern, then it's in order of n squared, because that's the most important part of this mathematical statement. But if they say, no, write the exact number of comparisons, then you have to do what I've done here. No, this is not a proof at all. Like this is just counting, right? Like we're doing counting, but we're doing it in a really, fashioned way to make our job easier. If you think about it, the only thing we're really doing is just tracing through our program in the end. We're just saying, hey, let's start from x1. Okay, I'll check you n times. So this is n. For x2, I'm going to check you n minus 1 times, and so on and so forth until you reach 2. And for the last one, I have to check all of them because it's not inside list 2, so it becomes n. That's how it goes. It's not really a proof. Rather, let's think of it as just counting, but you're counting in a really good order to make your job easier. Everyone good on the same page? Yeah, good. The last one would be 1 if xn was the first element. So if instead of having y in list 2, you had xn, like if these two were the exact opposite, instead of having y, you had like xn here. And then yes, instead of n times, we'll just check xn once and boom, it's here. And so in order to make it really, really worse, we are just going to exclude xn from these two, just going to have something else like y or whatever, such that we have to count n times rather than 1 time. But that's just a small part of it. Like the main idea is this n squared, because this will get repeated over and over. And if you're really curious to see where does n squared come in, if you think about it here, we have for loop, and this is running contains, which is defined using another for loop. So even though it's separate, we have a nested for loop. We have a for loop inside a for loop, and each of them are running for about n elements, maybe lower on average, since you could finish quickly, but on average is n, so 2 n's being multiplied gives you n squared. And that's the type of order we're talking about. So if you see nested for loops, most of the time it's going to be multiplying your lengths and increasing the order to quadratic, to cubic, etc. But don't be fooled. Sometimes a for loop might just run for 5 times always. It doesn't really matter if you increase the length or not. So it depends on your exact code. Alrighty, moving on. So this was the example we talked about. And just to wrap it up, what is the best case? You guys talked about it. The best case is in which the first element does not exist, right? Because that's the first element we check. We do not have it contained, so we return false and we're done. Yes, this function needs length to be equal to. Because if you think about it, if length of LST2 is bigger than LST1, then you have to do more comparisons if your items are in the end of list 2. So you could just make everything worse and worse as you go. So it could be a good practice to see if your length of list 2 is M and length of list 1 is N. What is the order? But that's going to be a bit challenging. Anyway, so the best case running time is easy. The first item is not in the list, so we just return false and we're done. Right? You just do one for loop, one iteration, one if statement, and we're done. Now, the generalization of the best case is interesting. So what is your answer, guys? If you are given lists of length n, like they're both the same length and they're both length n, what is the number of comparisons we'll do in the best case? What is like the exact number, or what is the order? Is it in squared and cubed, order of n? What could it be? I'm going to see a couple of answers before I disclose it. But really careful, right? We're in the best case, which means we want to exit as soon as possible. Both of them are length 1. Okay, one person says constant, one person says order of n. The third person will close the deal. 1, exactly. So the best case occurs when the first element is not in list 2, which means it's just 1, right? It's linear. Now, again, this is n. I'm going to explain why this is n, but the best case is just 1. Your first element is not here, so you're just going to keep checking. Now, something that's tricky here that you guys say 1 is the difference of this example with the previous one. Because if you think about it, in the previous one, what happens is you're going to get number 1. You're going to see the first element is 0, so it's not contained, and you're going to return false, right? And that's one of the reasons this is going to be constant. So again, just to summarize it, what happens is, you're going to find x1, you're going to check x1 is not in y, so these two cannot have the same elements, and this will be 1. Okay, sounds good. This is a typo. No, yours truly, this is 1. Okay, I hope the example is understood by everyone. It's a pretty fun exercise to do. So the thing is, the first element is not contained in list 2, right? So the first element we find in this for loop, this is not contained. And so this is not contained, which means these two lists could not have the same elements anymore. If the first one is not contained, then we just have to return false, right? Now, I guess the reason for this confusion is the way we've defined contains is checking through all the elements, right? So I suppose, yes, this should be n. We check it. Let me see, because the confusion comes from this. Yeah, so the number of comparisons for list 1 will be 1, and for list 2 will be n. Because now this will clear it, right? So for the first element of list 1, you're going to keep checking through all the elements in list 2 because it does not exist. Then you're going to return false. So if you're looking for the complexity in terms of how many comparisons we're going to have for list 1 element, should be 1. For list 2 will be n. But yeah, I assume overall you have to multiply it, so you get n back. Does it make sense? So it's more about how you formulate the question, right? Like if your formulation is how many elements of list 1 will we go through, then it's 1, always. How many elements of list 2 will we go through? It's going to be n. So overall, you're going to have an n by 1 multiplication. So you have n comparisons, and your order will also be n, which is not constant, which is going to be linear. Yeah. Does it make sense now? I also got confused. It's pretty fun exercise. Amazing. Let's move on. So let's do some smaller, easier multiple choice questions for iterations. Now, this one is not that hard. I guess you guys can solve it. We have an index. We're going to set it to I. For j in range I plus 1 to len of list, we're going to do an if comparison. Is the jth element of list less than basically the ith element of list? If that's so, the index of smallest will be j, which means we're going to update, right? We found a number that's smaller than I, so we're going to update our index to j. So how many iterations do you perform? And just for people who are a bit confused, let's say LST like this list, has a bunch of elements. I is here, and we're saying for j in range I, all the way in the length of list, if the LSTJ, which means the jth element, is less than the ith element, update the index. So what is it going to be? Does anyone agree with the mentioned answer in the chat? Okay, one person. Exactly. So I'm really happy that you guys understood that we have a for loop, right? So we don't really care what happens inside the for loop. We'll run for the set number of times we have. In other words, this whole thing is useless. Like we don't care what's happening here. And how many times that for loop will run? Well, it starts from I plus 1 and it goes all the way to len. So it's len minus I plus 1, which will give you len minus I minus 1. And that's answered. Great. Happy you guys were able to solve this one. It's a bit tricky, but you get the point, right? The for loop will always run for any number of times that it's set to. It doesn't really matter what happened inside the loop. Now, sometimes you see some people use nasty things like a break statement. Well, that will break the for loop, of course. But in general, you can be confident that your for loop will run for a constant number of times. Another one. So we have a following code, which is a function named f. And this is terrible naming for a function. Please name your function something reasonable in the exam. Like, f is not a good name. Maybe you can come up with a better name. And we have the function being run on an integer x, and it returns an integer. Now, we've run that on f of 10. Then we're getting the output, making the string, and then we're printing. So what is going to be the final result? And this is from 2022 final exam. This space is a bit too wide. Like consider this to be just one space. Why do we have two returns? That's a good question to ask, right? It means that the second return doesn't really matter, right? In other words, that two returns is there to trick you. It's not a good practice to have two return statements in the same part of the code. So in other words, what your friend is saying once we reach return x, none of this code will run because it will return the function. And that's one hint that will help you solve this question easier. So we do a print, we do a return, and then we do another print. So what is going to be the answer, guys? Yes, the answer is going to be C. So what do? We first go through it. We print, I got 10. Then we return. So you're done with the function. So we just print the end result, which is the output. Since it returned x, we just say we return 10. And so the answer is. So you see, the second return will not run. That's a key, or anything after the first return will not run. That's a key observation here. Moving on. So in which order are the functions called when the expression f, g, h, whatever is evaluated? Yes. So in other words, if your return statements are in different parts of the code, like one of them is under an if statement or one is somewhere else, then yes, maybe, based on the input, this return will run, maybe that return will run. But if you're just guaranteed to run one of the returns, let's say, it couldn't just be not using if, right? Say if in your code you have if true, return X, right? If you have this, the moment you reach this if statement, you're going to be running and you're done. So any return that you have here won't matter because you're guaranteed to return when you reach if true. So once you're guaranteed to return something, then you're done with anything after that. And in the previous question, we were done because we had a specific return statement saying you return. So that's it. It will return X, right? It will print and it will return X. It will not go through the rest of the code because once it returns X, it will not have F anymore. Like F will be done. And so it will not like add something to X or print something or return it again, right? It's already returned and it's done. Your functions are one-time usable, they will not keep running. Once they're done, they're done. You have to rerun them again if you need. So when you say f, g of h of x or whatever, which one is the order they're evaluated? So as you can see, we start from the most inner part. So h is evaluated. And then you keep coming out. In other words, you run h, then you run I, then run g, and then f. So you just start from the most inner part and you just keep coming up. Now, why is h ran before I? This is just because it's from left to right, right? We first run h and then I. But these two are in the same heart, right? They're in the same middle of the code. And once these two are both ran, then G and F will run. So IHGF is, this is just because it's from left, to right? Already moving on, we have sorting. So you guys covered sorting, right? Like the selections for that insertion sort. Yes, no? Okay, how does everyone feel about sorting? Not good, yeah. To be honest, that's true. Like sorting is, also agree, it's a bit complicated. And definitely the PCRS videos do not help. So what I do suggest you guys do is watch some good YouTube videos on sorting because you really need to see a good visualizations of how things are going to be able to grasp the idea of how sorting works. And if you do not have those videos in PCRS, then you have to find them from somewhere. Now, we have an example for sorting. I don't think we have any slide to cover how these sorting algorithms work. And I guess the best way is really just going through. Okay, I'll see in the break if I can bring some like good videos or good slides for sorting that we can add. But in general, definitive review sort. Here we have selection and insert sort. I guess you also learn about bubble sort, which are the main tree sorting methods you learn in AO8. For all of the sorting algorithms, make sure you know their best performance, their average performance, and their worst performance. So you know the order of what is the best input, what is the average input, what is the worst input for these things. And personally, I've never seen it in any final exam that asks you to implement sorting from scratch. So if you're feeling overwhelmed, especially with insertion sort, which is pretty long, you don't need to memorize like the entire algorithm, but you should be confident that if I give you like a sorting algorithm and I mask some part of it, I say, what is this line going to do or whatever, you have to be able to fill in the gaps. So I say memorizing these sorting methods are good, but understanding them is more important because that's eventually what's going to help you. Already, so let's fill in the blanks. We just talked about filling the blanks, and here's the question, and this was in problem. So you see, they do not ask you to do everything yourself. They give you a bit, but still, you have to know the sorting algorithms yourself. So what is this function? This function is getting a tuple as input. And a list of tuples along with an integer that it should be sorted. And so the goal here is to insert our tuple into the list of tuples at an appropriate position such that the tuples remain sorted by elements at index order. So this is just examples. If your tuples is an empty list and you're saying insert, grade 20 in this tuples, then it will just add. Pretty easy. However, now our tuples has one element. So if I say add another element with CSCA08 and 5 and add it to index 1, we will add it in the beginning. And the reason for that is number 5 is smaller than number 20, right? So we want CSCA08 to come first. And if you want to do the same thing with is10 to the same tuple, then you need to add it in the middle because 5 is smaller than 10 and 10 is smaller than 20. So this is not alphabetical order. This is the order that's defined by the index in the top. Now you might be wondering, well, how do you know that, number 20 is in this first index, and that is the sort by index that's given to you. That's why we have an index number 1 in all of these examples telling us that the 1th element in that tuple is the one that determines the index. So for example, if you have, let's say if you have grade 21 as a single tuple, you'll only look at the first, not the 1th index, which is this, and you'll use that for sort. So are we all on the same page? Does the question make sense? Now I can go through it, but I'm going to give you guys a bit of time to actually implement this. It's not that straightforward. So yeah, take a couple minutes, think about how you can implement it. You start from an I equal to 0, you have a while loop, and then you're inserting in your tuples, which is a list. And once you have a suggestion, write it in the chat. Okay, well, top sort by is less than tuples I. So, okay, I'm not going to say it's correct or not. Just going to see your answers coming in. And you also have the tuples that insert that you have to fill. Now remember, tuples is a list. So it's the same insert method in the list that you guys have learned. Anyone else with suggestions? Like, I want to give you a hint. In your while loop, your main goal is to update I, right? In other words, you want I to be at the right spot for insertion. So you have to check a condition that will allow you to keep increasing I up to a point that you are in the right position. And the right position is defined by that your tuple is, bigger than the ones before it and smaller than the ones after it. If you say while I is less than length of tuples, then your I will just go in the end, right? That will not really sort it. It will just find the last, it will just insert in the end. Your goal here is to use a different condition that will understand where should I stop increasing I. Yeah. Anyone else with suggestions? All right. Yes, this is getting pretty good. So I guess you guys now know the correct answer. There are in fact two things that you need to check. And None of you get correct answers, but if you guys collaborated on the exam, you would get correct answer. But you shouldn't collaborate. Anyways, moving on, you need to check two things. One of them is, as all of you thought about, is this. You need the, let's say, the index of your tuple, let's say the number that it's coming with, to be larger than anything before it. So you're going to keep checking for that. Starting from I0, you're going to say, okay, at the 0th element, give me the current tuple and give me the number that it has. And for the current tuple that I have to put inside the tuples list, give me the number it has. And while I'm bigger than it, just keep going one by one until you find a sweet spot in which, I'm bigger than anything before me, but the next item is bigger than me, so I should not move further. But you have to be careful with one thing, and that is you cannot pass on the length of tuples. In other words, if you are bigger than all the elements, you have to be inserted in the end, right? And as a result, once your I becomes equal to length, you should not keep increasing it because you've passed on, the border. So you have to stop the moment you reach the last part of the list. And so in the case that, for example, let's say you're adding tuple C with number 50 inside our list, your I will just keep getting bigger and bigger. It will be bigger than 5, it will be bigger than 10, it will be bigger than 20. So it will be added in the end at index, it starts from 0. This is not working. So I becomes 1, I becomes 2, I becomes 3. It will be added at index 3. And the insertion is the same thing you've seen. You put the index and you put your tuple and it will be added into this. So just to summarize what happened here, there are two observations. One of them is you want to increase your I. You want to keep going through the list to find a sweet spot. And the way you want to find that sweet spot is by comparing the element responsible for sorting to the current element in the tuples. So for our, I want to sort my tuple inside this list. I'm going to just keep checking. Is it bigger than the first tuple? Yes. Is it bigger than the second tuple? Yes. Is it bigger than the third one? No. So I found a sweet spot. And that's where I end the while loop and I will go insert it at that position. But in the scenario that I'm bigger than all the elements, I want to add it in the end. I don't want to pass on the length of the list. So I'm going to also add a second condition. At the moment you see you're out of bounds, stop and go add it in the end of the list. So this is pretty, nasty, the way I would say, because many of you will probably come up with this one. But coming up with this one is a bit hard. And that's one of the reasons you should really check and think about the code you're writing. Does it make sense why we have two conditions that we're checking? Okay, one person understands out of 65. That's progress. 2 people. Only 2. Maybe some people are in the meditation room having fun. I don't know. Is anyone there? Right, 3 people. I'm satisfied. 3 is good. So definitely go through these examples to make sure you understand how things are working. And we have the next one. So now you guys learned about my insert. My insert was this function. The goal was again to add a tuple in a list of tuples in the right position. And the element of the tuple you would choose to compare is the element at sort by index. Now, what you're doing here, you're saying you're using that inside another function. Now, what does your bigger function is trying to do? It takes in a list of tuples, and it just takes the sort by integer, and it will sort the tuples inside that list. In other words, you'll start from a list of tuples that might not be sorted. There are like some tuples just randomly thrown at it. And you want to end up with a list of tuples that's just nicely ordered and sorted. The precondition is sort by the value index, etc. So everything makes sense. And you can see the example. If you're just trying to sort an empty list, you get an empty list, right? If you're trying to sort this list of 3 tuples, then you get the same list, but now they're in the correct order. How do you use the previous function, whose job was to add a tuple into a list at the right position, to make sure all the tuples are in their right positions? We'll go over that you mentioned. Okay, I'm glad all of you are on the same page. You should start with an empty list that's going to have the sorted tuples as we go. Then what do we do here in my insert? Just to remember, the first one is a tuple, then there's a list of tuples, and there's the sort by. So, what should I write? No, we have these, and we have these. So we just want to bring them together. Exactly. So you want to say my insert starts with tuple, correct order. Then you have sorted tuples, which is the list, and you have the sort by index. And you're done. And that's what we have here. So we start from an empty list. We add that, we go through each of the tuples. We add the first one to that empty list. We add the second one in the correct order. We add the third one in the correct order. So we're reordering everything as we go. And then we return a new list that has all the sorted tuples. Now, one of you asked that it's so confusing to go through tuples and dictionaries and lists and how we slice them. So just to do a quick summary, and if you're wondering how I created a white page here, this is sort of magic. As you can, I guess list is something we've already gone through. Like a list, it has a bunch of elements, say 0, 1, 2, etc. And you can easily index it by saying which element you want. You can also slice it by saying which groups of elements, for example, you want. And there are all sorts of other things you can do. That's easy. What becomes challenging is dealing with dictionaries and tuples. Now, tuples, think of them as, again, similar to lists. Instead of being defined by brackets, they're defined by parentheses. They have differences like, you cannot change the items in the tuple while you can't change the items in the list, etc., etc. But the slicing is still the same. You will say my tuple, I'm going to say TP, my tuple, whatever element, I can extract it like that. And I can also slice it, right? So the slicing works the same. The only difference is you cannot change the values in that tuple. The tuple is, they call it immutable, whatever. You cannot change the values. They're fixed once they're created. Now, a dictionary is a whole new thing because in a dictionary, you don't have any internal order, right? What you have is key and value pairs. You might have, a name, like my name, then you have my grade, which is maybe 80, hopefully. And then you have like different name, maybe, maybe Jacob is here and Jacob's getting 100. So this is a dictionary. Now, even though you see it in a specific order, it doesn't really have an order. Like internally, the only thing that matters for slicing a dictionary is saying what key you're referring to. Are you looking for the Adib key or the Jacob key? And based on the key you pass on, the dictionary will return to you the value associated with it, which is, in this case, 80. So you could do a lot of nasty things, right? You could have a dictionary of a string, but this string refers to a list, right? Now you might say, oh, this is so confusing, like, I'm mixing things, but the same idea is, again, valid. You might say, okay, I want Adib as my key, and I want the first element. And this should give me, now if you go through it one by one, it will give me the list here, and then it will give me the first element of that list, which is number 1, so I get 1. And of course, you can just keep going, right? You can define like can define a list of dictionaries. Why not do the opposite? You have a list here, but each item is a dictionary. Here is like, I'm going to just make it smaller. So we have space, like A refers to 1. That's our first dictionary. Then we have a tuple of, dictionaries. So we're just going to cook something up. We take 2, whatever. And now I'm going to say, what is LST? 1, 0, B. And you're going to say, oh, it's equal to 2. And the key to solving these types of really nasty things is just by going through it one step at a time. LST1 is the first element, or the first index. The 0th of that one is the 0th element of the tuple, which is a dictionary. And the B of that dictionary will give me number 2. Now, someone has asked, can you use functions like range or length for dictionary and tuple like you do for list? You can use length. In general, you can use len for a lot of things, a lot of data structures. Like len of a dictionary will give you the total number of pairs you have. Len of a tuple is the same as len of a list. It will give you the number of elements in it. But range depends on how exactly you're using. So for example, you can say for elements, in tuple. Right? That's the way you say for element in tuple, for element in list, both of them work. Just go through the elements of that blob tuple or list. But you can't say for element in dictionary because dictionary doesn't have any element. It has key value pairs, right? Think of dictionary as a person that you give it a key, it gives you a value, something like that. But you might be wondering then, how do you go through the, the items of the dictionary? And there's a built-in function called dict.items, and dict.items will give you the items one by one. So you can say for, for key value in dict.items. And what it does, it goes through the items of the dictionary, and each time it will assign the key to this variable here and value to this other variable. And you can call this anything. You can say for, A and B, dict.items. It's your average for loop. Why does it have two variables? It's just because an item in a dictionary has key and value, so they're a pair. You can't just get one of them. Now you might say, well, what if I just wanted the keys in the dictionary? Then Python is like, well, you have to say dict.keys, and this will give you just the keys. So you can say for any key inside dict.keys, give me that keys. And that's how it goes. So it's quite, it seems like English, and just make sure that you're comfortable with this idea of having two variables in your for loop. They get assigned as you go. Okay, does it make sense, guys? It's a quick recap. And I guess this is a good time to move on to Encrypt, right? I mean, when we're registering for loops. Okay, let me stop sharing. Let's take a 2 minutes bio break, or no, 5 minutes. We'll be back at 7:15, and then we'll go through the rest.
Okay, so we covered a lot of stuff about sorting. I just want to make sure, do you guys have any questions about the thing? Anything about sorting? So we had insertion sort and selection sort, and there's also a thing called uh, searching. Do you guys have any questions about that? Yeah? No? If you guys have any questions, say yes, and if you don't, thumbs up. Mm, who can't see the reactions, or is it like nobody reacting? Oh, okay. That is something. Okay, I can't see the reactions for some very reason. So it would be good if you can speak or type it in the chat. Two options, speak or type it in the chat. Okay. So wait, what were the reactions? Can somebody just type it in the chat to tell me what the reactions were? Do you guys want me to cover it again, or what's happening with searching sorting? Or just speak up. Like I'm perfectly fine with anybody just unmuting. Because we got to be fast. No. Okay, I will assume that everybody is fine with that stuff and move on to the next topic, which is searching and string and loops. Okay. Uh, if you guys were in my midterm review seminar, I like to do one thing. 20 seconds, and I want everybody to read this question. Just 20 seconds and read this question. Once done, just a yes in the chat would be great. Try it. Like you have a pen and paper, try it completely. Yeah. Okay. Let's look at the solution for this. So what is happening? Strings and loop. Let's take a look at an example from the final to review loops and string manipulation. So there's this function called as def make word, which takes in a string, which is text. And then what does it do? Return text converted to lowercase with all leading and trailing non-alphanumeric characters removed. Return text converted to lowercase with all leading and trailing non-alphanumeric characters removed. Okay, so what is this doing? It starts with index is equals to 0. What is this index is equals to 0 is more or less, in very generic sense, a looping variable. So when you have to loop in while loops, you have a condition here, and this condition is the terminating condition for the while loop. So if this is false, the while loop will end. It will go here in some sense. This index variable, the looping variable, is the very variable which keeps on changing inside the loop in each iteration. So if you can see here is uh, while index is less than length of text and not this not is important text at the character at index if that is alphanumeric, then what do? We increase the index. Is everything fine till now? I don't necessarily like this online thing, but yeah. Okay. If you guys want me to go a bit fast, we can go, but the later slides should be faster. Okay. So what did we do? So if we had this as our input, we check index is less than text, index is less than length of text, and at this very index, for example, 0, if that is alphanumeric, if it is, then we move on to the next one. If it is, then we move on to the next one. And then we keep on going in something. And then we, at a point, what do we have? We have something like this. So this is a string manipulation here. Having string as A, B, C, and I'm doing um, does anybody want to tell what will this give? BC. Okay. Uh, just a quick, I know you guys typed in fast. It will be BC, that's fine, but it will be this. These curly or the this thing is very, very important. And in if I'm not wrong, this question was in one of the finals where the options were without the commas or with the commas. And the correct answer was this. Okay. Once we have that done, we can move to the next part of the answer in some sense. Index is equals to length text minus 1. So we had a particular index which we got from here. We're reducing it by 1. And then what are we doing? We are looping in a very similar sense. We are looping in a very similar sense. And at the very end, we get something like this. This should be easy. This is more like my syllabus too. Okay, is everybody kind of fine with it? Just have one example thing and loop.
Could
Oh,
you
yeah, this is the question.
sorry, yeah.
Yeah.
Could you repeat the part after we made index is equal to length of text minus 1? Like that part, could you repeat what went down with that?
Okay. So we are at length of text minus 1, right? And then what are we doing? We are reducing the index. And how much are we reducing the index by? Okay. So
By
see,
1.
take this example. We reach some index here, for example here, and this is the index, which is the last index that we can consider. So it will be somewhere here. So index right now is this. So at this very point, our the text looks something like this. This is the text, the highlighted portion. And then In the next part, we are trying to reduce it. And then we end somewhere here. And at the very end, we are left with 100.50. Does that make sense? So what are we doing is, if we get this string, 100.50 question mark exclamation space, and this is the string that we get. We first try to find what is the last, or in some sense, which one of this is the first one. So we find this here. So the text then is this. We found the first boundary, and then we start from the very last. We start from the very last, and we keep on reducing the index until we find a alphanumeric character. We start from here. Is this alphanumeric? No. Is this alphanumeric? No. Is this alphanumeric? No. But if zero alphanumeric, yes, it is. So we stop here. So at the end, what do we have? We have 100.50, and we also need to convert all of them to lowercase. So we return this 100.50.2 lower. Does that make sense?
Yeah, that makes sense. But what if we had something with an alphanumeric variable in the middle? Like, for example, like the first one, like Anya123 had like Anya at 123. Then would this still like work?
Okay. I want you to read the question for that. So the question says, with all leading and trailing non-alphanumeric. It doesn't talk about the ones in the center. So if there is any, suppose at the rate, you said this, there is an at the rate here, that will still be present in the string. Cool. Is this clear? Any questions for this strings and loops? We just have one question, because this is more or less covered earlier too. Any question? This is your time, guys. Like, we not necessarily want the same or similar results as the next time. So make sure you understand every single point. Okay, if there's no doubt, then we'll move to the next one. The next topic is about files. So what is a file? In AO8's language, or in the language which you can easily understand, and how I tell students who ask me is this. So in very simple terms, a file is a very long line. It's a very long line with all sort of special characters. So if on Notepad or on a text editor, you're seeing, hello, hi. If you're seeing this, the actual file is something like this. This is a line, just a single line. So yeah, this is more or less how a file looks like. When you open a file, this gives you a file stream in some sense. So a file pointer at the very start of the file in some sense. Yeah. And the bigger question here is, how are you opening a file? You can open it for reading, you can open it for appending, and you can open it for writing. Now, there's some caveats attached to it. This is pretty much simple, and you probably have done this in A3. So I won't go over it, but just read it once for the next 20 seconds. And there's something you can't understand, please do ask. Cool. Okay. I'm checking the chat. Does anybody want to respond? Yes, no, doubts, problems, what? Okay, I'm waiting for the chat. R and W and A all open the file, right? Okay. The opening of a file is a bit different. As I said, open of a file is done by this function, which is the open function. And then when you see this mode, so this is the type as you want to open the file with. So all of them will open the file, but how you're opening the file depends on this. And opening of a file is not done by this mode, but by this function highlighted in orange. Yeah. Any other questions? No? We have a total of 112 slides and we are still at 66. So we will try to be fast now. Okay, file methods. File.read, file.readline, file.write, file.close. So I talked about a stuff. This is a file in some sense, a very long line. What does file.read do? If this is a very long line, it will read the whole thing at once. So it will open the whole file at once. It will open the whole file at once, the whole thing. It's a method for reading from the file. By default, it returns the entire content of the file. Okay. What is next? File.readlines is a method for reading one line from the file. By combining your knowledge of loops, you can read line by line from a file. Okay. So what is it? File.readline. If I'm having, I had that. Hello, backslash n, hi, backslash n, A08. So, if this is the file, what will file.readline return once, when is it, when this is done the first time? What will this return? File.readline. Hello. Okay. And what will it return the second time? Hmm. Hmm. Okay, hi, I get it. Good. So, how is this happening? So, file.readline is having a pointer, a cursor somewhere here, and it is going through the text until it finds this backslash n. The moment it finds this backslash n, it will return this. The second time we do it, the pointer is already here. The cursor is already here. And then if we do file.readline, it will go until a point it finds this backslash n. Until a point it finds this backslash n, and then it will return hi. And then so on. Note, there's also a function called as file.readLines, which returns all of the lines in a file as a string. So that would be, this is hello, comma, hi, yada yada yada. Okay, so this is about reading. What about writing? File.write is a method for writing to a file. For example, file.write good luck for your final exam writes a line into the final review.txt file. Into the final review.txt file. So final review.txt file, we had opened it here. And how had we opened it? Is it not hello slash backslash n? Okay, so a friend of yours asked, hello, would it not be hello slash backslash n? So the backslash n is more or less a new line character. This is a special character defined by Python itself, or the developers of Python, which is used to segregate lines. As I said, in simple sense, a line or a file is a single line, a single very long line, which has all these symbols like backslash n. And backslash n is used as a delimiter or a separator for these lines. So the question was, is it not hello backslash n? No, because backslash n is just a separator. It's not part of the string. Okay. Then we have file.write. Now, can anybody answer as to where will this write to the file? Will it be at the start or at the end, or uh, in the middle somewhere? Okay, it's gonna be at the end of the file content because we had earlierly opened it with append. If this was W here, then it would be from the start. If this is not W, then if this is A, then it would be at the last character of the current file. So like appending to the current content. Okay. File.close is more or less deleting this pointer. You remember we had this pointer which is helping us move around stuff. So we don't want to keep this open forever. And we would return the file. We will delete the file pointer or like close the file. Okay, file.close. Okay, let's go over this first. Consider the following code. How many list objects are there in the Python memory after execution of the following code? Ten seconds. If anybody wants to answer in the chat. Okay, a lot of people are saying one. Okay, let's no, it's not. It's actually one. It's not three. So what is happening here is when we are doing A is equal to this 1 to 3 list, this is initiating a list object for one, and every other time we're just uh making the other variables. Like if A was equal to ID1, B also became equal to ID1, and C also became equal to ID1. It's not like we're creating those IDs again and again. If you remember, we had something called as a memory model. Yeah, that's like an older topic. You should know this by now. So we create this for the first time at A, and every other time we are just assigning the value of A to B. We are not creating it again. Okay, cool. Okay, we don't have the answers marked here, but one is the answer actually. Okay, let's see this. Consider the following code. What is the output of running Python file with the following content? 10 seconds. I want everybody to at least go through it. Okay, there's one for C. Okay. There's D coming in. Okay, this is not okay. Think more. Is this D or is this C? Okay, there's confusion there. B or C. So you start from here. So L is 1, 2, 3. You go here. You go where? You go into the function. So you're here now. This is line 1, line 2, line 3. You make a new list, line 4, which is 10, 11, 12. Then you come back to this. Mm, okay. So what is L at this very point? Is it this or is it this? It's one of these two. Okay, I think now people have kind of got it. Them are saying this B. Okay, it is B because when you're working in this very function, the memory of the function is local to itself. You're not passing a list like that. For example, if you would have something like here, if this was L at 0 is equals to something like 1, then that would change things. But right now, when this is saying L is equals to 10, 11, 12, this is creating a completely new object. So earlier, when we were here, L was having ID 1, then we went in the function, and then L got assigned a new ID. The L got assigned a new ID, which was ID2. Why did it get assigned a new ID? Because of this equality, not equality, assignment operator, sorry. This assignment operator created a new list. So then that becomes ID2. And then you're back at line 5, and then you're trying to print L. And this will always print which L? This L. This line will always print this L. Always. The trick would be if this very L got changed itself and we change the values in ID1. This is a bit confusing. This was also in your midterm, I'm not wrong. But yeah, is this clear now? Finally, I hope so. If anybody has any questions, please do ask now. Okay. Assuming not. This is the correct answer. Yeah. What is this? 5 seconds. We're gonna be quick with this. Yeah, I need 3 more answers and then we'll move on. Please be quick. Okay, okay. Okay, I can't wait more. This is gonna give an error. Why will this give an error? Because we're having A is equals to 1, 2, 3, and then we're trying to access 3. So A is having 0, 1, 2. These are the indexes. There is no third index in this. So this will give an error because you're trying to access something which is not already present. So error is the right answer. Okay, because of this thing. Next question. These are all past paper questions, which means they are very similar to the ones you'll probably have in your final. So take them seriously. Yeah, done. What is the solution for this one? Anybody? Okay, we are getting B and C. Think before you write. This is a good one, I guess. Somebody said A. Okay, people are saying A now. Okay, some people are still on B. Think, this is a good one. That's I'm spending time on this. Consider the following code. What is the output? So this is a line 1. We initiate this. Okay, initiate this. Line 2. We change the value at index 0 in the list of A. No, I'm blind. That's this time. Sorry. We change the value at index 0 of A, which is this now. And then we append 200 to this. To what? To A. Okay, the last one. Let this be the deciding factor. What is the solution for this one? No. Okay, let's see what is happening. This is a difficult one. So we have an ID for A, which is these lists, storing these lists as lists. Then we make B is equals to, so if A is having 1, and then this ID1 here is storing a list of ID2, ID3, and ID4. What did we do? We made B is equals to ID2. We made B is equals to ID2, the first element in the list. Okay, that's fine. What do we do next? We took A0 and we changed it. We didn't modify it. We assigned a new ID to it. So then what happened? This ID changed and this became ID 5. Why did this change and not modify? Because we were using the assignment operator. We were using the assignment operator. Okay. So this changed here. This remained the same. ID1 still remains the same. We're not getting a new ID for A. We're just changing the ID for the list in the list. What do we do next? We appended this with 200. So what is being appended? This one is appended with 200. And then we're saying print B. But B is still ID2, which was not appended. How will you modify it? Okay, that's a good question. So the answer for this is this. How will you modify it? So can you see I did not change A. The A remained same all throughout. How did I modify A? By more or less considering a particular value in it. Or you can use other functions like so you have A dot, like basically A is equal to now you can like if you do something like this, uh, that would not change the value or ID of A, but will only change the actual ID inside the list. And that makes sense. So the actual ID of A will remain the same in some sense. Does that answer your question? On a generic note, what happens here is if you are using proper Python functions, then the value is modified rather than it being changed. But if you're using these equality operators, then this is actually changed. Why there is a different ID with the same value? Okay, why there is a different ID with the same value? That's also a nice question. Uh, and my counter question to you is why there can't be a different ID with the same value? The IDs don't have, in some sense, a value is not corresponding to an ID. It is an ID which is corresponding to a value. So this, how do I say? If this is ID1, this is the number 4. ID2 can also have the number 4, and these are completely different from each other. They don't have to relate to each other because the program deals with this. It doesn't care about this thing. It only deals with ID. So yeah, more or less. This is just a convention that they have made. Very basic. Okay, we need to be quick, guys. So yes, this is Q1 and then this. Now I want everybody to answer this correctly. You have like 20 seconds. Okay, there's one guy saying A, another person saying A. Okay, yeah, this is the correct answer. Okay, I think everybody got that now. Yeah? Okay, I'm moving on to the next one because I think now you guys have properly understood what is happening. Okay, I think everybody got that. Yeah, this is the correct answer. Mm, yeah, let's go on to this one now. What about this? If you guys have any doubts, please do just unmute yourself and ask it on spot. Okay, so somebody said C and then somebody said A. A lot of people are saying C. Okay. Think. What is this? Equal to. Is this creating a new ID or is this changing the ID? Is it actually changing the ID? What is it, guys? Is it creating or changing the ID? It is creating a new ID. The equal to always creates a new ID. We have been discussing this since this. Uh, Equal to create a new ID. Equal to create a new ID. Equal to create a new ID. So it always creates a new ID. So when you're changing this will still remain the same. And what I told you earlier, when you're printing A, this will always print this thing. If this got changed in the middle, then that's a different case. But in this case, it did not get changed because every time we try to change it, we created a new ID for that. So the original list remained the same. Okay, so this is going to be 1, 2, 3, 4, 5. Any doubts in this one? No? Yes, no. I can't see your reactions, by the way. So if you want to interact, type it in the chat. There are some questions about the tuples. Uh, we will go over this, but I want to cover the other stuff first. Yeah, the questions about the tuples, I'll take that later on. Let me cover dictionaries first. Wait, did Adip cover dictionaries in the last hour? Anybody just confirm that? Yeah, only briefly. Okay. Hmm. So dictionaries are unordered collections of key value pairs. We can get the first and the last element in a dictionary. The value can be any type, including another dictionary. So you can have a dictionary in a dictionary like infinite. Yeah, you can go on. Okay, that's one thing. But the keys are immutable data types. One ones that cannot be changed or modified. Yeah, this is basically just explaining what immutable means. Valid keys are ints, floats, strings, tuples, etc. And invalid keys are another dictionary, list, etc. So you can't have a list or another dictionary as a key. This is easy. Any doubts in this one? Uh, Another sense, is everybody clear with this one? The general introduction. Okay, assuming that as a yes, let's move on to some functions with dictionaries. So we have the in operator, the length function, and the dot items method. So the in operator checks if a particular key is in the dictionary. The length function gives you the number of key value pairs in the dictionary, and the dot items method is something used to loop for all the items in the list. So we go to one of them, truth cost. If I'm doing apple in truth to cost, the answer is true because this thing is here. If I do peer in truth to cost, the answer is false. Okay. Then another function is, this is a dictionary, and I'm trying to do length of truth to cost. This will return me the number of key value pairs. This is first, this is second, this is third. The output is three. Another one is truth, a dictionary, and then I'm looping through all the items in the list. So You can't really loop through a dictionary, but you can only loop through its keys or items. So if you do this instead of this here, you will be looping through all the keys in the dictionary. So that would be in some sense, or no, the items, sorry, the items would give you the whole thing. Then there is something as keys, and there's something as fruits dot values. So that would only give you this thing 4.5, 3.5, 2.5. Also, another way of dealing with these items is rather than using a loop like this, you can change it to make for item comma value in the same thing. So then that will mean your value is directly initialized to this variable and your item is directly initialized to this key. Yeah, it's just a variable by the way. Is this clear? Hmm? Yeah. If this is not clear or you have any doubts, just unmute yourself and please ask them. If not, okay, let's move on to the next one. Dictionary dot values, as we discussed, allows us to loop through all the values. Dot keys allows us to loop through all the keys. Assignment operator checks if this thing is uh, having a or creates a new item or creates a new key in the dictionary with the corresponding value. So if I'm doing something like here with 4.5, then what is happening? I'm adding this key value pair to the dictionary, and then I'm trying to print it later on with the key here. The value for this would be 4.5. Is this clear? It's touching close on time. Okay, I'm assuming this is clear, hopefully. Okay, test cases. This should be quick. Generating test cases, figure out what you're testing. That's the first thing. Testing with or without mutation. What makes a good test, good set of test cases? This is just text, and I want you all to like read through this in like 30 seconds. There's no point in me reading it and then, yeah, repeating it. Done? Yep. Oh, hmm. Let's move on. Generating test cases. This is a old test question. Generating test cases. Try this for the next 1 minute. Just think as to what can you write here. And this can be a template that you can follow for your test cases. Okay, a person asked me, would we be requested to write unit tests as well? Not like you will just be asked to write the generic test cases in which, in some sense, we can cover the edge cases for that very question. So, yeah, we'll go over the edge cases, edge test cases. This is a very important table. Take a screenshot of this if you want. This will be posted, yeah, this will be posted. It probably is the only thing you need to know for testing. Okay, this is the solution. We consider an empty list, which is always there. One list, longer list with one minimum element. Okay, yeah, with more than one min. So, yeah, 3 plus 1, and with all of them as equal. So, see, this is a good test suit out of 3. Yeah. The thing with test cases is like it's probably the easiest question on the final. If you understand this table and you're able to like think on spot, you should be good to go. Just make sure you're writing the description very properly. Okay, we can go over this quick review. This is all the stuff from before the midterm. We're good on time, yeah. Okay, this is the last question of the review seminar. The generating test cases. Try this one. And take a screenshot and remember this thing. Okay, we are on time. Let me just share the solution. This is the solution. Does anybody have any doubt for the same? Yes, no? Could I see the question? Yeah. So the order is basically same. You always have a empty list, one list with no x, one list with x in it, longer than x, long list, multiple x, long list, no x. So if you compare this solution with the solution here, empty one, more than one, uh, and then this is a special case with longer, with multiple mins, and then there is one with all of them as mins. So the generic idea for writing test cases remains the same for all questions, which is something like this. Very important. Okay. Now, we have more stuff here. This is all about your midterm one syllabus. We're not really gonna cover this right now, but the slides will be posted and you are recommended to go through them. The answers are attached to it. Yeah, we covered doc strings here. A lot of people have questions about doc strings as to how to write doc strings. So this should serve the ultimatum to writing doc strings. Let me see if we have any good questions here. all covered earlier. Yeah. Okay. So the slides will be posted. Review the quick review slides and the last 10 slides because we didn't cover them properly. But other than that, good luck on your final and remember the passcode for this Zoom meeting, which was, I hope everybody gets this. Can everybody just say 100 in final right now? In not in chat, but in voice. Yeah, no,
100 in final.
yeah. Can more people say it? The thing is, A8 final is gonna be this. It is very easy, but you need a very good presence of mind. If you review your midterm solutions, or not midterm solutions, if you review your midterm uh, feedback on your midterm, you'll realize you know most of the questions. But in the exam, you sit there, you think about the solution, and you're like, I don't know this. But if you think twice, you think thrice to the same question. Sometimes just reading the question helps. You'll get this. Yeah, manifesting 100 and final. Oh, yeah. Can we have more 100 in the final right now? This is the last component of the review seminar. You guys should think better of yourselves and keep that presence of mind in the final. And I'll just post the slides right now and on Piazza. The slides will be posted on Piazza, everybody. So keep a check on that. Also, just want to mention about one other thing. There are notes available for you. So these are my notes when I took A08. These are not the best notes, but they are something, and I've shared them in Piazza with everybody. So if you want, you can go through all of them. These cover how linear search works, how binary search works, with some diagrams, explanations, how sorting works, selection sort works, insertion sort works, and the final ultimate and what purpose for in all these algorithms. Okay, that is more or less it for this review seminar. Thanks for coming. I might see you in the final while invigilating. Best of luck, everybody. What's the best way to prepare until the final? The best way to prepare until the final is to do a lot of practice, not do the things which you already know, but focus on new stuff. This is specific to A-weight because the material is very easy and the questions you mess up are the questions you absolutely have no idea. If you know a little bit about how to write a for loop and what searching means, uh, you can write any question or like you can solve any question related to searching just with the basic idea. Where you mess up is when you don't have any idea as to what is happening in the question. So this is the tip for the final, presence of mind. I'm not gonna write, that won't take for too long. So presence of mind, uh, do a lot of practice. That might be reviewing your PCRS questions. Some of them are really good. Doing your assignment again is also a thing I think people do. Let me pause the video recording first. Stop it. That's it for the review seminar.